फटाफट सीख लो. साइंस टीचर वेरी क्रूअल मांगे फीस कोई नहीं क्यों जी. I would be discussing D and F block elements. So let's start without further delay. Okay, guys, come on. Let us start with the first MCQ. So here it is. Electronic configuration of a transition element X in a +3 oxidation state is argon 3d5. What is the atomic number of the element? See, this question is in a twisted way. 3d5 means I've got to add up 3 electrons. So I'm adding up 3 electrons. What do I get? 3d6 and 4s2. I will, these are tricks. Naturally, when the electron leaves, 2 electrons leave from the 4s and then it comes to the D, isn't it? So naturally, you have to fill up 2 electrons in the S and then come to D. When you're losing 3 electrons, it is this 2 and then 1. So that you get a calculation of D5. I hope the maths is correct for you all. So the electronic configuration of the element 3d6 4s2 matches with, yes, what have you said? Did you say iron? Yes, it is correct. Atomic number 26. Shabash. Very good. Carry on. Chalo. Agle wala. Metallic radii of some transition elements are given below. Which of these elements will have the highest density? Oh, it's too simple. Density is mass by volume. Pick out the element which has the highest mass. That will have the highest density. So I hope you are familiar with the atomic numbers. Yes, atomic number of iron is 26, nickel is 28, cobalt is 27, and copper is 29. So 29 protons for copper. So is copper the answer? Yes, it is. Come on. Correctly done. Next. The magnetic nature of elements depends on the presence of unpaired electrons. Identify the configuration of the transition element which shows the highest magnetic moment. So you should have 5 unpaired electrons. So D5 is the maximum possibility of having 5 unpaired electrons. If you go to D7, the pairing starts. Array, aren't you all understanding what I mean to say? Wait. Just hold on a second. 1, 2, 3, 4, 5. So you know that this subshell has 5 boxes. So there are D5 subshells. So this is the maximum possibility of having unpaired electrons. So if I put D7, 5, this is the 6th one, this is the 7th one. So the pairing starts, so I have only 3 unpaired electrons if it is D7. That means D5 gives me the highest number of unpaired electrons and it will have the highest magnetic moment given by the formula mu equals to square root of n into n plus 2, where mu equals to square root, probably it's not visible, n into n plus 2, where it gives you the number of unpaired electrons. So do the calculation, you get the correct answer. Going to the next one. There are 14 elements in the actinoid series. Which of the following element does not belong to this series? Actinoid series. Uranium, yes, it is actinoid. Uh, Fermium, yes. Neptunium, yes. Thulium. Thulium is a 4F element. So yes, you have to know your elements, and if you want to know the tips and tricks of learning the D block elements, the F block elements, do watch out my further videos. Not in this. Come on. Let me keep something for later. Which of the following is an amphoteric oxide? अरे you will tell me by heart, by heart, by heart कितना करे? करना है ना? Marks चाहिए ना? चाहिए तो करो, नहीं चाहिए तो मत करो. अपना मर्जी है. So the answer is vanadium pentoxide and Cr2O3. This is a pair of amphoteric oxides. What about Mn2S7? No. It is an acidic oxide. So yes, so you've got to find out, some ways to remember things, some ways to go ahead with things. So this is the answer. Do remember it. So it's information, you can say. Build up your own knowledge bank. Yes, interstitial compounds, transition metal compounds where the small atoms are trapped inside the crystal lattice of metals. Which of the following is not the characteristic property of interstitial compounds? They do have high melting points, we know it. They are very hard, of course, because of the trapping. They retain their metallic conductivity. Yes, correct. They are chemically reactive. If it has to be either it will be reactive unreactive. So the correct option is they are chemically reactive because they have trapped some atoms inside their lattice. So it is D if you have correctly guessed. Very good. Let's go to the next one. Which of the following statements is again not correct? Not correct. To focus on the not correct, because they create a lot of stress for you. Let's see. Copper liberates oh, come on. This is the first one and the correct one. How can copper liberate hydrogen from acids? It is not, because it comes below hydrogen in the EMF series, so it cannot. Good. We got the option in the first option itself. That means the others are correct. Aren't you reading the other options? Aren't you gathering some information? Please do it. Please do it. Yes, we go on to the next one. You would have to read the correct options in order to build up your knowledge bank, because D and F block elements involves a lot of building of knowledge. Oh, the most interesting assertion reason: in transition elements, the radii of 5D series are virtually the same. Virtually the same as those of the corresponding members of 4D. If you take out the graph, you should look at the graphs. So if you look at the graph of the radii of the transition series 5D and 4D, that's very close to each other, very, very close to each other. And the reason is the filling of the 4f orbitals before the 5D orbitals results in a regular decrease in the atomic radii is a perfect answer, a perfect reason for the question. So a perfect reason, absolutely nothing wrong. Okay, going to the next one. The ability of oxygen to stabilize the higher oxidation states exceeds that of fluorine. Absolutely right. If you did not know, you know that oxygen and fluorine both can stabilize high oxidation states, but the ability to uh, for oxygen to stabilize the high oxidation states is definitely more than fluorine. If you did not know, please register it. And the reason says the highest oxidation number in the oxides coincides with the group number. The highest oxidation number in the oxides, not the oxides. All right, of course, it coincides with the group number, but in this case, the highest oxidation number of the metallic oxides coincides with the group number. Probably the presentation is a little wrong, but yes, the reason is correct, but it does not give you a reason that why oxygen will stabilize the oxidation states more compared to fluorine. Though both are right in itself, the reason is not sufficing the assertion. So B, B. And the last but not the least, please hang on, it's just a few minutes. Zirconium and hafnium occur together in nature and are difficult to separate. That you must be knowing that they are called chemical twins. Yes, if you didn't, once again, it's information for you. Reason zirconium and hafnium have identical radii due to lanthanoid contraction. Not only they have lanthanoid contraction, they fall in the same group. All right, so that is why everything matches, group matches, and the properties matches. So naturally, the reason and the assertion, they are hand in hand. So yes, A is the correct answer. So yes, I am done with my whatever information I had to give for DNF block elements. If you think that you have gained something, some quick tips, so do keep watching and do not stop subscribing and watching, of course, and recommending it to your friends and fellow mates. Thank you so much for watching.